we're going to talk about the determinant. And for every square matrix, so that's a 3 by 3, 2 by 2, 4 by 4, you have a determinant, and that's going to be some real number value. You're going to have a specific value attached to the matrix. And so the determinant is noted as either DET of some matrix A, or what looks like absolute value bars of A. That's talking about your determinant. Now, whenever you go through to actually find that determinant, that's going to look a little different. You're going to have what we call downs minus ups. You're going to say A times D, so A times D minus C times B. That's your downs minus your ups. Your down diagonal minus your up diagonal. That's going to give you your determinant value. It's going to assign a numerical value to that determinant. All right, so for number 1, whenever we're going through these, you do need to keep in mind that we are going from the matrix to a determinant, so we are changing those brackets to bars, and then we're rewriting our elements. And then you're going to go through and do your downs minus your ups. In other words, we're going to take this diagonal downward, and we're going to say -4 times -10. That's going to give us 40, minus, and then up, which is 15. And so 40 minus 15, that's going to give us 25. Okay, looking at number 2, again, same pattern with this. So you are dropping those brackets, and so you will change this to your bars and bring over your elements. And now you can say your downs minus your ups. You can assign that value. So in doing so, you're going to say -6 times -2. That's positive 12 minus -33. And I would put in the minus the negative just so that you keep your signs separated and you see what's going where. And so that does become plus a positive, and that's going to give you 45. Okay, so for number 3, again, same process. We're going to rewrite our matrix in determinant form. And then you're going to go through and do your downs minus your ups. And so you're going to get -45 minus 35. And so that's going to give you -80. And then number 4, again, changing this over to a determinant. And then downs minus ups again, you're going to get -16 minus 24. And so that's going to give you -40. The first thing that you're going to have to do is to rewrite your first 2 columns. That's super important for us to do, and we're going to write that to the right of the matrix. And then you're going to look at the sum of the products of each downward diagonal. So now we're going to have more than one diagonal in our multiplication, and we are going to add each one of those. After we multiply the elements, then we add everything together. Then we'll do the same thing with the upward, and then we will subtract our downs minus our ups. So starting out with number 5, again, you do need to go ahead and rewrite this in your determinant form. So I'm going to bring down the bars again, and we're going to fill in 3, -5, 1, and then you're going to have -7, 4, and 5, and then 2, -5, -1. So there's your determinant. Now to find the value, you're going to rewrite those first 2 columns. So in other words, I'm going to bring this over and say 3, -5, 1. There's your first column. Remember, columns top to bottom. Second column, you're going to have negative 7, 4, and 5. So again, you're changing your matrix to the determinant form. You're rewriting your first two columns. And now you're going to go through the downs minus your ups, except for now you're going to have 3 different diagonals to work with. So your first diagonal would start here, and we are going to extend that all the way through. And so that product, you're going to have 3 times 4 times negative 1. So that's going to give us negative 12, isn't it? And then we're going to multiply the next column. Notice that's going to be negative 7, negative 5, and positive 1. So we're going to say plus, because again, we're still working with our diagonals. And that's going to be plus 35. Plus, and then again, multiply through here. That's going to be negative 25 times 2, so negative 50. And we need to put all of those together. So you have negative 12, 35, and negative 50. So if you put that together, you're going to get negative 27. Okay, now we've got all of the downs. Now you're going to turn around and go do the ups. So you're going to start down here at the bottom, and you're going to multiply all of that. So 1 times 4 times 2, that's going to give you 8. Plus, then you're going to have 5, negative 5, and 3. So that's going to give you negative 75. Plus, and then you've got negative 1, negative 5, negative 7, so negative 35. And so all that together, that's going to give you negative 10, what is that going to give you? Negative 102, I think. Is that okay? Now, here was your downs. Here was your ups. And remember, at the end of the day, once you've got all of this together, it's downs minus ups. So it's going to be negative 27 minus a negative 102. And that's going to give you 75. Again, you do need to rewrite this in your determinant form. And so you're going to have 6, negative 3, 6, and then negative 1, 4, and 2, negative 3, negative 6, negative 4. And then you need to repeat the first two columns, so 6, negative 1, negative 3, negative 3, 4, negative 6. Okay, and then you've got to do downs minus ups. And so here, starting out, we're going to multiply here. Here's the first one, multiply down. Is that okay? And so if we multiply that, what are we going to get? Negative 96, I believe. Plus, and then multiply here. What are we going to get? Positive 18. And then plus, and then multiply here. What do we get? Positive 36. And if I put all that together, you should have gotten negative 42. Okay, so there's your downs. And then let's go back and do our ups. Okay, so here, starting at the bottom, multiply upward. And that's going to give you negative 72. Plus, and multiply upward again. That's going to give us what? Negative 72 again, I believe. Plus, and then our last one, that's going to be negative 12. And so all that together should be negative 156. And again, it's downs minus ups. So you're going to have your negative 42 minus a negative 156. And so that's going to give you 114. A way to apply your matrices, and really this is the application of the determinant, and we've already looked at a couple of applications of multiplying matrices. Now for the determinant, you can use this to find the area of a triangle. And normally on the ACT, they give you the vertices of a triangle, and they always ask you to find the area. And this is a quick way to find that area given those vertices. So looking at number 9, the first thing you can do is set up a determinant using your ordered pairs, and then that third column is going to be a set of ones. So whenever you set this up, your determinant A is going to look like, and you're going to have -5 and then -2, and then we're going to put a 1 there, and that's just part of your formula. And then you're going to have 3, 9, and then a 1, and then 7, -4, and 1. So there's the setup for your determinant, and just like the previous problems, you're going to rewrite the first 2 columns. So rewriting those first 2 columns, you're going to have -5, 3, and 7, -2, 9, -4. And then you're right back to doing the downs minus ups. So we're going to multiply here. We're going to grab that first diagonal down, and that's going to give us -45, isn't it? Plus, and then we're going to get -14 plus -12. And so if you put all that together, you should get -71. Okay, now let's go do the ups. So for the ups, again, going through that, this first one, you're going to get 63 plus 20 plus, what was the last one, -6, and that's going to give you 77. Okay, so now keep in mind this area is 1/2 the absolute value of the determinant. So again, here was your downs, and so you're going to say 1/2, we can put all this together, comes the absolute value of downs, which was -71, minus your ups, which was +77. And so that's going to give you 1/2 times the absolute value of -148. So the area of that triangle is going to be +74. So for number 10, it's the same idea. You're going to have some coordinates here, and do make sure you pay attention to the navigation that they're giving you. Wellspring is 14 miles north and 3 miles east of Chester. And then, what is that, Hilford, I guess, is 8 miles east and 5 miles north of Chester. So you need to find the area of the land between the 3 towns. So really, Chester, that's kind of the starting point, right? Everything's going from the point of view of Chester. So we're going to say Chester's ordered pair, well, that's where we're starting. So we're going to call that 0, 0. It's where you're starting from. And then notice that Wellspring is 14 miles north and 3 miles east. So that's going to be 14, 3. And then we're going to address that. Look at Hilford. It's 8 miles east and 5 miles north, right? So if I did north and east here, Then in the second ordered pair, you have to also do north and east. So if I want to do 14, 3, then what does my ordered pair have to be for the next one? It would have to be 5, 8. And again, the order that you put these in, just as long as it's northeast or east-north, you're good. The determinant, did y'all start with 0, 0? Maybe. All right, so you have 0, 0, 1, don't you? And then you have 14, 3, and then 1, and then 5, 8, 1. And then, of course, you do need to recopy your first column and your second column. So 0, 3, and 8. All right, and now you're going to do your downs minus ups. So if you find your downs, that first one's going to be what? 0, isn't it? Plus, what's going to be the next one? 0. Plus, what's going to be the last one there? 1 what? 112. So is that your downs? Okay, minus, now let's go do the ups. So that's going to be 15, isn't it? And then you're going to get 0 and 0. Row zeros is always nice, isn't it? So 112 minus 15 is going to give us what? What did y'all get for that? 97. Okay, and so your area is going to be 1/2 times the absolute value of the determinant. And so that's going to be 97 over 2, or what was it, 40.5 square miles. Talk about the identity matrix. And the identity matrix here is noted by I and then sub n. So there's your identity matrix notation. Now, the thing is, whenever you're coming down here looking at an identity matrix, A is an n by n matrix and I is an n by n identity matrix. And they're telling you that because you remember when you multiply matrices, your dimensions have to line up so that you can multiply them. Notice that what's going to happen is your matrix A times your identity matrix is going to be equal to matrix A. It's just like multiplying by 1. And this is also commutative. So matrix I, or your identity matrix times A, is still A. And earlier we saw that multiplying with matrices is not commutative. We saw that with a couple of examples. But here we're saying with the identity matrix, it is commutative. Order will not matter when you're multiplying with the identity matrix. Now, what an identity matrix looks like for a 2 by 2 is going to be a row of 1, 0, and then 0, 1. That's how you would have a matrix that has a value of 1. With a 3 by 3, that's going to be 1, 0, 0, and then you're going to have 0, 1, 0. And then 0, 0, 1. That's going to be your identity matrix for a 3 by 3. Okay. Looking at the other, talking about inverse matrices, notice that two matrices are inverses of each other if and only if you have a matrix B so that A times your matrix B gives you the identity matrix. That's going to let you know those are inverses of each other. Or you could even say B times A and get the identity matrix. That's how you know they're inverses. So that's what I'm going to be looking for in problems 1 through 4. Now, the notation for an inverse matrix, if you have an inverse, then you're going to write it A to the negative 1. That notes your inverse. And then you can say, well, A times A inverse is 1, or A inverse times A is 1. That's where our identity matrix will come from. All right, so let's look at number 1. And number 1 here, they are just asking us to determine whether or not the pair of matrices are inverses of each other. So in other words, I'm going to multiply these two together, and if I get that 2 by 2 identity matrix, then I know they're inverses of each other. So looking at the first one here, remember with multiplying matrices, you had to take your row and you multiplied it to each column. And we can do some mental math here to save a lot of this writing. Now keep in mind, when you multiply them, again, we took the row from that first matrix and we multiplied it to that column and we added those together. So in other words, we said -1 times 5. Well, that's -5, isn't it? And then 2 times 3 is 6. So -5 plus 6 is a 1. And then we went and multiplied to the other column. So we have -1 times 2. So -2 plus 2. So that's going to give us 0. And then you swapped and went to another row and you multiplied through to each column there. So for that first element, we're going to have 3 times 5, so 15 plus -15, so that's going to give us 0. And then our last element here, when I multiply that one through, I do get a 1. So notice the product of those two gave me the identity matrix. So these two would be, yes, they are inverses of each other. Okay, so for number 2, again, you need to go through and multiply. You're looking to see if these are inverses of each other. And again, row by column. So if I take that first row and I multiply it to this column, that's what I'm looking for to see what I get. So you've got -6 times -5 halves. Well, let's see, what is that going to give us? 10, isn't it? Is that going to be 10? And then we're going to get -9. So that element ends up being what? It was 1, isn't it? Okay, now let's go to the other and multiply. So that's going to be what? 6 and -6. So that's going to be 0, isn't it? Right here to here. So it's -6 times -1. And then it's plus -3 times 2. So that's going to give you 0. Okay. Going to the next one. Here again. Multiply those. So that first element, you're going to get -15 plus 15. So that's going to give you 0. And then the last one, you're going to get, let's see, -9 plus 10, so that's going to give you a 1. So are these inverses of each other? Yes. Okay, looking at number 3, again, if you take that row, multiply it to this column, first thing that you get, you're going to have 48, and then plus, oh, what are you going to get again? 48, isn't it? So that first element is going to be 96. That's not a 1. So these would be no. Those are not inverses of each other. Okay, so now let's look at number 4. And again, you're taking your row, multiplying it to this column. Again, don't let fractions kill you. You've got a calculator. Use it. So here, That's going to be a positive 3/4, isn't it? So I'm going to go over here and say, well, that's 3/4 plus, and then what's the next one going to be? That's a positive 2/8, which is a 1/4, isn't it? And so, gosh, isn't that going to give us a 1? That's going to be 4/4, which is 1. So this is looking like it might be an inverse, but we do need to keep going. So same process again. We're just multiplying over here. So that's going to be 3/16, isn't it? Plus, what is the other one going to be? 6 over, well, we can make that 3, negative 3/16. So that's going to be 0. So I would bet that this is an inverse. What do y'all think? So if you move down to this one and multiply that one through, that's going to be positive 1 and negative 1. So, yeah, that's going to give you 0. And then the last one for sure, that's a 1/4. And then 3/4. So, yep, that's going to give you a 1. So these are inverses of each other. Your first step with trying to find the inverse is just to make sure you will have an inverse. And you're not always going to have an inverse. For the ones that don't have an inverse, then that's going to mean that your determinant is going to be equal to 0. That's what that's going to mean. So here, first thing, always find your determinant. And then after you find the determinant, your formula to find that inverse is 1 over the determinant. You change places with A and D. So you change places with the first and fourth, and you change the signs of the second and third. That's a lot to remember off of that, so we're going to go through a couple of examples to help us. No matter what, first thing, always go find your determinant. Always find the determinant. So now we're back to a 2 by 2. So the determinant here, remember you have 4, negative 6, negative 1, 3. We said down, so that's going to be 12. Minus up, so that's going to be a positive 6. So that determinant is going to be 6. So it's non-zero, so you do have an inverse. We're going to go find it. So now we're going to say A inverse equals 1 over your determinant, so 1 over 6 times. Start your matrix. It is a matrix, not a determinant, so do go back to your brackets. You change places with the first and fourth element. So 3 and 4 are going to change places. The other two elements just change signs. So it's going to be positive 1, positive 6. Now multiply through to get your inverse. So 1/6 times 3, that's 1/2. 1/6 times 1, 1/6. 1/6 times 6 is 1. And then 4 times 1/6 is 2/3. So again, find your determinant first. So your determinant for this one, have 8, 2, negative 4, negative 1. All right, negative 4 and negative 1. Yep. All right, so what's our determinant going to be? Negative 8 minus negative 8. Ooh. So what do we get? 0. So do I have an inverse? No, no inverse. Okay, so now let's go to number 7. Again, find your determinant. So this determinant, let's see, what are we going to get for the determinant? 10 minus 36. So that's going to give you negative 26. So that is non-zero, so it does have an inverse. So we're going to have negative 1 over 26, right? It's just going to be a negative fraction there. Times, again, change places with the first and fourth. Change the signs of the other two. And now multiply. So if we multiply through, we're going to have 5 over 26. Negative, well, what is 6 over 26 reduced to? 2 over 13, maybe? Is it 3 over 13? Yeah, I do too. Brain fart. Okay, and the next one is positive. Nope, it is still negative 3 over 13, isn't it? And then what's the other one? 1 over 13. All right, so for number 8, woohoo! So downs would be 40 minus ups, which is a negative what? 80. Oh, goodness. So what's our determinant? 120. Well, it's non-zero. So 1 over 120 times, swap places with 5 and 8. Change the signs of your others. And multiply through. 5 over 120. Holy cow, what's that going to be? 1 over, oh my gosh, 5 goes into 12. 24. Okay. And then we've got 1 over 12. What about 8 over 120? Oh my. Negative what? 1 over 15. And positive 1 over 15.